Through a series of simple steps, you can make some knobs that make it look as though you know what you're doing. And we can make these in both convex or concave. This video will go over the process for both. These are threaded on one side for installation, so you should probably use a hardwood. In this case, this one's maple. This one is black walnut. And you are not required to have a lathe for this, but I will assume that you have some kind of belt sander. Find yourself an attractive piece of wood that's at least an inch thick, and note the way that it's cut. In this case, I can see all of the growth rings, and that way, when it's viewed from the face, it really exploits the natural beauty of the wood. This will be the part that we see from the finished knob, so flip it upside down and we can draw two circles. A larger circle with a diameter of 2 inches, and the smaller of the two is only an inch across. Be fairly aggressive on that center point. We want to be sure that we'll see it later. Let's make a few cherry knobs too, because I have a well-suited piece of firewood. There's a crack in it that runs almost from end to end, which suggests to me that we can get it to split in such a way that will give us a flat face. And if we have a flat surface, then we can use it for crafting. That dark cherry color is closer to the inside of the log, so I don't need much. I'm just going to cut something like this away and then try to make it an inch thick and try to avoid this split right here. Over the years, it's been somewhat of a recurring theme in a lot of these videos, in both of my channels, that woodworking is a process of refinement. In order to make the thing that you want, you have to start with a rather crude approximation and then just make it better and better as you go. Never is it more true than the case of the disc sander, where you'll rough out a crude circle and then make it closer and closer an approximation of a circle. And as you do this, you should move closer to the center of the disc. The outer part of the disc moves faster, and so it will remove more material faster, but it will also generate lots of heat and thus burn. So note those differences. Next up, making a threaded hole for the knob. We're threading in a piece of 1/4-20 rod, and so it would be reasonable to think that you drill a 1/4-inch hole, right? Wrong. They're both pieces of 1/4-inch rod, but the one on the right has threads cut out of it, and so the threads go in deeper, which makes it considerably smaller than 1/4 of an inch. And so the bit that I'm using is a 13/64 brad point bit. That teeny tiny point there will help us find our teeny tiny hole. Also note the piece of masking tape. It's just a visual reference for the depth. We'll be using this reference distance for two things. One is our little jig that we'll use to spin our knob. If the threads sticking out are deeper than that distance, then you run the risk of running the thread too far into the knob and it will push out on it and split it. You'll also need to note that distance on your tap, which we'll get to in a moment. Set your depth to 1 pencil width away. A little piece of vinyl tubing will help protect your taps. They have a tendency to chip one another as they roll around in a toolbox. Similar for your more expensive bits. But today we're going to use the vinyl as sort of a depth set because it's going to hit against the chuck of the drill and only allow us to run the tap so deep. At this point you can chuck it into the drill just to see how true it spins. But it really won't matter much to the finished product. Don't try to be perfect, just try to be perfect enough. A sensible approach to problem solving is to begin by stating the obvious. A knob is designed to pull. As such, its design is a very deliberate reflection of that function. Form follows function. And the roundness of this belt sander can give me a perfect finger cove. But the problem with it is that if I try to sand the cove here, this is just going to flick the knob right out of my hand. And if I try to do it here, I can't see. But this tool does have another side. Just above the vacuum port, there's a place for me to put a flat surface, and then I can adjust the height of that flat surface until I get the cove that I want. A portable belt sander is effectively the same tool, except it's upside down, which is a good thing in this case, because we can rig it up to do exactly the same thing, but it will take 4 clamps, one to support the back end, one to set a working surface and attach it to the table, one that attaches to the belt sander itself so that we can adjust its height. It's worth pointing out that this one has an elastic band on it, and that keeps it from vibrating loose. And finally, the 4th clamp attaches that anti-vibration clamp to the rest of our assembly. Depending on what type of wood that you're using and the condition of the belt, your mileage may vary. Just expect it to take a little bit longer if you're using a portable belt sander. One of my favorite belt sander tricks is to use one to chamfer things that would otherwise be too difficult to chamfer. I like this trick so much that I have a dedicated machine and dedicated belt sander to the purpose. And this could make a nice finishing touch, unless you want to make your knob either convex or concave. Let's do a concave one first. We can use a table saw blade to scoop a tiny dish out of the center of the knob by turning it over top of the spinning blade. Not as dangerous as it sounds. First, we set the fence so that the center of the blade is exactly in line with the center of our circle. Easy enough on a 2-inch knob, 1 inch to the center of the blade. Next, we want to position a stop block so that the knob is centered this way along the blade. You can find this center mark by pretending that the blade is a perfect circle, and imagine where this tooth stops right here where it intersects the plane of the table saw, and also find the opposite point here, and then just find halfway in between those 2 points. Now we lower the blade height because we're just taking a tiny scratch out. Remember that you have the thickness of a pencil to work with, but we don't even want to take anywhere near that much. Consider for a moment that I'm using a 7 1/4 inch blade. If I were to use a smaller blade, it would have a smaller diameter, and thus it would take a smaller scoop out of the center. I recommend that you don't use anything larger than a 7 1/4. 1 inch back from the center mark. And with the blade raised back up, you should be able to see clearly that it's nowhere near the stop block. If it is, you have it set too high. Here's a simple tool that can help keep our fingers out of the way. Adding a bearing will make this work even better. Compare the size of the flat spot that's part of the profile on all three of these knobs. In the case of a convex knob, we're going to be shaping it by cutting down into this. Remember that hole begins a pencil's width down. But that only applies to the middle, and we're going to stay clear of that. Instead, we're going to shape from the outside a curve that moves in until it's non-existent at the center. There's a certain approach you have to take to the next part. Your natural inclination might be to keep to the interior of the disc sander and swing it around, but if you do that, it will come off the threads. The correct way is to keep yourself and the drill to the outside of the disc. Once you understand this, you'll sort of get it and it becomes quite natural. Nothing left now but some sanding, and thankfully it's pretty easy to do. There have been quite a number of techniques shown in this video, but it's really up to you to assemble all of the pieces together in a way that applies to your own application. So before we close, let's think about some of the different purposes that these might serve. When somebody says knob, they mean one of two things, as long as you're in polite company. That is to say, they're either male or female, but there is a secondary consideration, and that's permanence. In the case of a drawer pull, you're not going to be spinning it on and off frequently, unless you have to repaint something. And so you can do something like this, in which case I might put a single drop of epoxy on these threads just to keep it from ever coming back out. But if your intention is to have a male knob that's spun on and off constantly, then it would be a good idea to put multiple drops of epoxy on the threads. And that brings us to the problem of having wooden threads on a female knob that we want to take on and off a lot. A possible solution is to insert a T-nut. We could also drill it out and insert a coupler nut. But coupler nuts are expensive. We can reduce the price by cutting them in half, and we would still get twice the threads of a normal nut. But in the spirit of thriftiness, let's try another experiment. We have two nuts that are free to spin on this piece of all thread. And if you find the sweet spot, you can spin them both at the same time. And so that's where we'll epoxy them together. Little tiny piece of modeling clay is some insurance that I can get the threaded rod back out. Now we raise the deck up to it, just so that the nuts end up a little bit proud. The deck is set, and so now we're using the drill press to help epoxy this in nice and straight. And then finally, I drilled and tapped the wood underneath, right through the nuts. You just have to mind your depth. The reason I did this was so that I would get more than 2 nuts worth of depth. And now it can be finished in the same way that the others have. And with that, we can call this one done. Alright, if you found any of this to be helpful, then try to extend to me the same courtesy. Do those little things that you can do to help further this content. You know what they are. I don't like to have to ask. Okay, until next project, craft on.